All right, we're ready to begin, so you can begin anytime there. In Goal 6.1, we are dividing monomials, and with that, we have 3 rules that we need to talk about before we do our questions. You will be having a goal assessment on this next class, so make sure that as we're going that you're very clear about my notes and that you ask questions, okay? First of all, we've talked about some exponent rules last semester, and we're going to use those again in some of these questions, but these are the 3 new rules that we're going to use, okay? First of all, when our bases are alike, so these are our bases, the A's, and that can be a number or a letter, it could even be a quantity, okay? Our rule is to subtract the power. So in long form, let me just show you why that works. So for example, if I had x to the 5th over x squared, that's the long form of that. And I could mark off x over x because that equals 1, and I could mark x over x because that equals 1, and that leaves me with an x to the 3rd in my numerator. But much simpler, I could have just taken 5 minus 2 and gotten my 3. Okay? You've actually used that rule without knowing you've been using it when you factored. Okay? The second one is when I have a negative power. When you have a negative power on something, that represents a really small quantity, less than 1. Okay? When I have a negative power on something, and in math we don't ever leave things with negative powers. Okay? We get it to the actual number it represents. In science you would leave that. That's why we have negative powers, because science works with very small numbers and very large numbers. So they have negative powers, and it's okay to leave negative powers in science, but in math we do not. So when we have a negative power on something, we're going to move it to the opposite place and make it positive. So when you have a term in your numerator with a negative power, it's going to move to the denominator and become a positive power. The rule works both ways though. If you have a negative power on something in the denominator, we're going to move it to the numerator and make it positive. Okay? There is a way that you don't always have to do that with using the first rule, but I think it's easier, so we're going to do it. It might require one extra step, but in the long run, I think you'll make less mistakes. Okay? And then lastly, anything to the 0 power is 1. The reason for that is this. So like if I had x to the 3rd over x to the 3rd, that would equal, cancel, cancel, cancel. That would equal 1. And if I had subtracted those powers using my first rule, 3 minus 3 would give me 0, which is why anything to the 0 power is 1. Okay, so anything to the 0 power, a simple monomial term to an entire quantity to the 0 power. Okay? All right, so we're just going to go through some examples now using these 3 rules along with rules that we've applied before. Okay? So we're going to simplify, leaving no negative exponents. 12 over 6, so we're going to reduce that first. 12 over 6 is equal to 2, and x over x would cancel. Done. Negative 8 over negative 12 reduces to a positive 2/3. I'm dividing 4 into each of those. My x over x would cancel out. And my 2 minus my understood 1 would leave me y to the 1 power in the numerator. This could be written as 2/3 y. I personally like 2y over 3 better for myself, but it's the same thing. Seven to the 5th over 7 to the 2nd. My bases are alike, so my rule is to subtract the powers, and I get 7 to the 3rd power, which is 243, I think. Calculate any numbers to a power. Okay? So subtract my exponents because my bases are alike, and then calculate your 7 to the 3rd. 32 over negative 8 is negative 4. And I'm going to talk about these x's now. This is where I can use the rule 2 ways. Okay? I am going to subtract because I'm dividing. But since my power is larger, in the denominator, I'm going to subtract that direction. So instead of taking 3 minus 5 and getting negative 2, and then switching the negative to the denominator, just know that when you have to subtract your powers, subtract in the direction of the larger power. So 5 minus 3 is x squared, but in the denominator. And then on my y's, y to the third over y, that's an understood 1. 3 minus 1 leaves me y squared in the numerator. Any questions you want to jump in with so far? They're pretty quick questions to do when you do them on your own here. Okay, on my x's, 4 minus 2 leaves me x squared in the numerator. My y's equal 1. And on my z's, 7 minus 2 leaves me z to the 5th in the denominator. 7 minus 2, larger powers in the denominator, so that's where they're going to stay. (36 over negative 24), looks like I can take 12 into both of those and get a negative 3/2. My x's, I have x over x to the 12th, so that's an understood power of 1. 12 minus 1 is 11 in the denominator. My y has nothing to simplify with, so leave it. And my z has nothing to simplify with, so leave it. These bases look almost alike, but they're not exactly, so I can't just subtract powers. So I'm going to simplify using first my rule that I used from last semester, that the power on the outside goes with the powers on the inside and they get multiplied. So this is going to give me 2 to the 2nd, x to the 6th, over 2 to the 3rd, x to the 6th. So what I'm doing is I'm just multiplying my powers. Understood 1 times 2, understood 1 times 3. If you want to make that 4 and 8 immediately, that's fine. Okay? And then I simplify. 2 to the 2nd over 2 to the 3rd leaves me 2 to the 1 in the denominator. 3 minus 2. My x to the 6th equal 1, so they cancel. So I'll have an understood 1 in my numerator. So 1/2. My bases are alike. Negative x to the 8th over negative x to the 3rd. So that's going to give me negative x to the 5th power, which can be simplified one step further. If I'm going to take a negative x times a negative x times a negative x times a negative x times a negative x, 5 negatives, my answer is going to be negative, and then x to the 5th power. So negative x with parentheses to the 5th power equals negative x to the 5th. Had this power been an even number, a 2, a 4, 6, 8, whatever, then my answer would be a positive answer, because an even number of negatives would make that positive. So that's why I want you to go one step further past those parentheses, eliminate them, so I know that you know whether it's positive or negative. Okay, we're going to get into some of our negative powers now here. 3 to the negative 4th. Now I realize that you could just punch this in your calculator and get an answer, but I want to make sure you know how to do it without a calculator, so that, because when you're working with variables, you can't use your calculator, okay? So 3 to the negative 4th is the same thing as 3 to the positive 4 in the denominator. So I'm moving it down. I then have an understood 1 in my numerator. And then calculate your 3 to the 4th. 3 times 3 is 9, 27, 81. So, as I said, negative powers mean that you have little numbers, 1/81. 3 to the negative 4th, a really small number. Here, from last semester, my rule is multiply those powers. So I have 2 to the negative 6th, which is the same thing as 2 to the positive 6th in the denominator. So understood 1, which is 1 over 64. You have some options on this next question. Personally, I don't like working with negative exponents. So the first thing I would do is I would put them together. In my numerator, I am multiplying, so I would put those together. And when you multiply from last semester, we add powers. So negative 3. So I multiplied first. Multiply means add the powers. Now I would move my powers. So x to the negative 3rd comes to the denominator and becomes positive. And x to the negative 5th comes to the numerator and becomes positive. So when you have the negative power on a letter or a number, you can move it or should move it to the opposite place, and that makes the power positive. Now, I could have just used my subtraction rule, but I will just say that I tend to see a lot of mistakes with that, so that's why I don't do it. Now I'll subtract. 5 minus 3 is 2. So x squared is my final answer. Okay, when I'm multiplying on my next one here, I'm going to multiply my x's together. So I'm going to have 3x to the negative 8th. When I multiply my x's, I'm adding the powers. So you do have to remember your rules from last semester. And now I'll simplify this by moving my x to the denominator, making my power positive, but my 3 stays where it is. So 3 over x to the 8th. A lot of these questions are very short, little work. I'm getting to some ones that are going to be more work here eventually. For x to the negative 3. When you have that power, it is only on the thing it is right behind. So that power, that negative 3, is not on the 4. It is only on the x. So when I want to make this power positive, I'm only going to move the x. So that comes down and becomes positive, but the 4 stays where it is. Which differs from this next one that looks very similar. But here I have parentheses, which means the whole thing moves down and becomes positive 3. So I have an understood 1. And then I simplify that. 4 to the 3rd power is 64. And then x to the 3rd power. 1 times 3.